This is Science Max. Experiments at large. Science Max!
This is a balloon, and this is an orange. When you put them together, a chemical reaction happens. How'd you go in there for a minute, didn't I? No? No? All right. Well, you can actually do a chemical reaction between a balloon and an orange. You see, balloons are made of latex, which is a kind of polymer that's very, very stretchy. And orange peels contain a chemical called limonene. Limonene breaks down latex. To make slime, take your white glue and pour in an amount. It really kind of depends on how much slime you want to make. Now, you want to add about twice as much water as that. Yeah, somewhere around there. Great. Now we want to put in just a little bit of soap. Maybe there, that's good. And you want to put in your food coloring. I like green. Green seems like the right slime color to me. It's the right appropriate mad scientist kind of slime. And then you want to start mixing that up so you get the right kind of consistency. That means make sure the glue and the water are equally mixed up. Good. And now we're ready to make it an actual slime by bonding the polymers together by adding liquid starch. Very good. And you want to mix it up. When you add the liquid starch, it starts to bond the chains of molecules together, changing it from a liquid to a slime. It's coming along. And there you go, slime. Now,
Thank you.
this is magnetic putty.
10 take.
This is magnetic putty.
26.
This is magnetic putty.
2,635.
This is magnetic putty.
I can't count this high.
This is magnetic putty. Magnetic. Oh, it's not a magnet. It's attracted to magnets. Oh, that makes more sense. This is magnetic putty, and this is a magnet. The putty is made of polymers, which means it can flow over itself. It also has lots of iron filings in it, which is why it's attracted to magnets. This is what happens over several minutes. And there you go, magnetic putty. When you set a domino on its end, you're giving it potential energy because it can fall. Ooh, and when you put two dominoes together, you can start a chain reaction because that one will fall into that one. But it's a lot more fun with more dominoes. Setting up a run of dominoes is a lot of fun, but it takes a flat surface and a steady hand. And if you want to do it yourself, add gaps, so if one part falls, it doesn't take out the whole run. Last one. There. I had some dominoes left, but I did it. I made the Science Max logo. See?
Science
right?
Max!
Sort of. Let's see how it works. Ready? Yeah! This is an egg. It's been hard-boiled and peeled, so there's no shell on it. This is a flask, and this is hot water. I pour the hot water into the flask, which means the air inside the flask starts to heat up. And when it heats up, it expands, and some escapes through the top of the bottle. I pour the water out, and then I cap the flask with the egg. Now this expanded air is starting to cool again, which means it's lower pressure, which means the higher pressure on the outside of the flask pushes the egg in. Ha-ha! Fun! And then, to get the egg out, I can reverse it. If I blow into the flask, I can increase the pressure inside. Science! And now let's max it out. It creates light using a chemical reaction. There's a liquid chemical inside and also a glass container that holds another chemical. When you bend a light stick, you break open the container and the two chemicals mix, creating light. There you go, light sticks, chemical reaction. And yes, of course we're gonna max it out. This is a whole bunch of the two chemicals in a light stick. Let's max it out. Here's what I don't get. This is heavy, but I can still pick it up and throw it.
Yeah.
An airplane is way heavier. I could never pick up an airplane, but that can fly.
And that's because airplanes have engines, so it has a constant source of thrust. When we throw it, we just have an initial source of thrust. So we're throwing it, eventually loses its energy, therefore
It falls to the ground. I see.
So we need something that's light, and something that's strong.
And strong. Okay, well, let's see what we can find.
All right.
Sonia and I try a plastic tube and some heavy-duty paper. We make hoops and attach them with some duct tape and run outside to try it out.
Hoop glider dance! Okay. Oops. An egg. Now you might think of eggs as kind of flimsy, and they do break pretty easily, but eggs are actually stronger than you think. It's because they're, well, egg-shaped. You see, the top of the egg is like a little bit of an arch, and the bottom of the egg is also like an arch. And arches distribute the weight, just like they do in a bridge. Here's how you can experiment with how strong eggs are. First, you want to get a pair of gloves to protect your hands from the shell, just in case anything goes wrong. You should also tell an adult that you're doing this experiment because if it does go wrong, you're gonna have some mess to explain. And also, you should probably put on some safety glasses. Now, here's what you do. Take your egg and carefully put it in your palm, just like that. And put it against your other palm, and you're gonna push in directly on either side of the egg. Start pushing harder and harder. You can even lace your fingers and press even harder. And if you do it right, the egg won't break. Pretty amazing, right?
Finding the perfect note things vibrate best at is great for musical instruments, but it's not great for this wine glass. The sound waves are causing the glass to vibrate a lot. And because this glass is delicate, it can only vibrate so much before it breaks.
The vibrations were so strong that the glass literally shook itself to pieces. Science! Sorry. Science! Oh, wait. Science! But you can't use camera tricks to help you. You have to practice to get faster. Now, you don't need to use official sport stacking cups, but if you don't know your science, some things will work against you. First of all, these cups have holes in the bottom, which makes them not very good as, cups. Why do they have holes in the bottom? Because of science. You see, when you pull the cups apart, there is air that needs to get inside this cup. If you don't have a hole, like these ones, the air makes them stick together because there's nowhere for the air to get in except for underneath, and they will stick. Once again, let's compare. Also, you want the cups to have some weight because if they have some weight, they'll fall out of each other easily. Can one egg support my entire weight? Let's find out. I'm gonna lift my weight up like this and lower myself down. And no, cannot hold my weight. Can my weight be supported by 2 eggs? Oh, nope. Phil's weight, 4 eggs. Oh, I thought they were gonna do it. Nope. My weight on 8 eggs. My weight can be supported by just 8 eggs. Science! Whoa, careful.
Changing the current going to the spiral in the middle turns it into a magnet. The more current I put in, the stronger that magnet becomes, allowing the ferrofluid to climb the spiral to the top.
And remember, even though it looks all spiky, it's still a liquid. I will demonstrate with my plastic spoon. And watch this. When I turn the magnet off, it stops being spiky. Turn it on. Turn it off. Science. Let's see what happens when we put them together.
There you go. Maxed out ping pong ball, mousetrap, chain reaction. Awesome.
Watch what happens when I drop a sodium tablet into this beaker of water. Very cool and very dangerous.
And this is chlorine, or Cl on the periodic table. Chlorine gas is very poisonous. So,
So, what happens if we combine these two deadly substances? Do we create some sort of super poison? Something more deadly than anything else known to science that causes fear and chaos in chemistry labs all over the land? No, we create salt. Good old normal table salt. Yep, the egg is totally fine. The parachute worked. All right, egg drop experiment, totally fun experiment to do, but the question is, how do we max it out? And the answer is pumpkin drop. Same thing, except with a pumpkin instead of an egg. Come on. Okay. All right, pumpkin drop with everything attached all at once. Okay, here we go. Ready? 1, 2, 3. So what we've learned from this is the heavier something is, the more force is acting on it from gravity, which means the harder it is to slow down when it's falling. Okay, fair enough. You win this one, gravity, but I'll beat you next time. I'm gonna get a broom.
Here we go.
Woo! This machine is called a Van de Graaff generator, and it pulls the negative charge away from the person touching it.
That is great!
Instead of having equal amounts of positive and negative charges, you become positively charged.
Woohoo! Science hair! Yeah!
Like when you try to put two positive ends of magnets next to each other, each hair on your head starts to repel the others and be repelled from your head.
Science hair! Dude!
So your hair stands up.
Yes! Woohoo! I can't see anything.